In calculation of time, EGA principle or EGA rule plays an important role. You can clearly see the direction. Okay. When the direction of travel is towards east, okay, when the direction of travel is towards east on the flat map, then you have to add 4 minutes per each degree. Whether your position is in western hemisphere or eastern hemisphere, it is not important. If your direction of travel is towards east, you have to add 4 minutes per each degree. If your direction of travel is towards west on the globe, if your direction of travel is towards west on the globe, even in eastern hemisphere, if you are traveling from 120 degrees east to 60 degrees east, then the direction of travel is west. Then you have to subtract that. Subtraction of time when you travel towards west, adding time when you travel towards east. These are the two important principles we have to remember when we calculate time on the globe. To understand the principles of EGA and WLS, let's consider these 4 examples. Okay. The line that you can see in the background, like the blue line that you can see here, the blue line is the prime meridian. What exactly this prime meridian is doing? The prime meridian is dividing the globe into 2 equal parts. So what they are? The eastern hemisphere and the western hemisphere. So consider the first example, that is Portugal to USA. Both are located in western hemisphere, but the direction of travel is towards west. The Portugal time zone will be forward and the time zone in USA will be behind the Portugal time zone, because the westernmost countries or westernmost longitudes will have time behind the locations which are located towards east of them. In the same manner, when a person travels from Mexico to India, from western hemisphere to eastern hemisphere, the direction of travel is towards east. He must add 4 minutes per each degree, that is between the Mexico and the India. The next example is Cuba and Guyana. From Cuba to Guyana, when we travel towards east, then only we can reach longitudes of Guyana. The longitudes of Cuba different, the longitudes of Guyana different. To reach Guyana longitudes, we have to travel towards east. So need to add time to Cuba time to get Guyana's time based on number of longitudes. Then India to Oman. In this case, what is exactly happening here in India to Oman case? India and Oman both are located in eastern hemisphere, but Oman is located to the west of India, so the direction of travel is towards west. Oman time zone will be forward compared to India's time zone, because we have to subtract from our time zone. Our time zone is GMT plus 530. As we are located to the east of prime meridian, our longitude for calculation of time is 82 degrees, 30 minutes east longitude. So 82 into 4, 328 minutes. 1 degree equal to 4, half degree equal to 2 minutes. Total 330 minutes difference between prime meridian and India's IST. So when we convert these 330 minutes into hours, it is GMT plus 530. Let's consider some problems related to longitude based calculation of time. The time at 60 degrees west longitude is given, that is 9 a.m. on Monday. We have to calculate the time at 150 degrees east longitude. The direction of travel is towards east. How many degrees travel? 60 to 0, 60 degrees. 0 to 150 degrees east, total 210 degrees of travel. The traveling is towards east. 210 into 4, 840 minutes. When we convert 840 minutes into hours, it is 16 hours. For 9 a.m. time, which is on Monday, we have to add 16 hours. When we add 16 hours, 9 a.m. to 9 p.m., 12 hours. Same day, Monday, same day. Once we add 4 hours, the day will change. This is based on total addition of hours. Okay, this is not based on international dateline. As number of hours went beyond 12 a.m. on the same day, automatically next day, that is 1 a.m. next day, the time at 150 degrees east is 1 a.m. on 1 a.m. Tuesday. When the time at 60 degrees west is 9 a.m. on Monday, the time at 150 degrees east longitude is 1 a.m. on Tuesday. Let's consider the second problem. Now the time at 150 degrees east is given, that is 9 a.m. Now we have to calculate the time at 60 degrees west. 150 to 0, 150 degrees, then 0 to 60, 60 degrees, total 210 degrees. Here now we have to subtract the time. Previously we added because the direction of travel is towards east. Now the direction of travel is towards west. So what we have to do, subtract the time. 16 hours must be subtracted. 9 a.m. on Monday, when 12 hours are subtracted, it will become 9 p.m. on previous day, that is Sunday. When 4 more hours are subtracted, it becomes 5 p.m. on Sunday. Now let's consider a problem based on international date. The time at 150 degrees east is given, that is 11 p.m. on Sunday. We have to calculate the time at 150 degrees west. So the direction of travel is towards east. So number of degrees traveled is 60 minutes. Before we calculate time based on EGA rule, it is important to remember that here international dateline principle is applicable. As international dateline is crossed from eastern hemisphere and entered into western hemisphere, we have to subtract a day. Sunday will become Saturday. Immediately after crossing international dateline from eastern hemisphere, when you enter western hemisphere, subtraction of day, Sunday will become Saturday. The direction of travel is towards east. 60 degrees travel, 60 into 4, 240 minutes, so 4 hours. 11 p.m., 4 hours added, it will become 3 a.m. Date we have to change and the date is Saturday. So if it is 11 p.m. Sunday at 150 degrees east longitude, the time at 150 degrees west longitude will be 3 a.m. Saturday. In this manner, we can use the concept of international dateline for calculating the time. Let's consider one more example related to international dateline. The time at 150 degrees east is given, that is 11 p.m. on Sunday. Okay, when the person is traveling towards, without considering the concept of international dateline. So the shortest 2 days, traveling from 150 degrees east to 150 degrees west by crossing international dateline. Suppose a person thought about moving in towards prime meridian and then going to 150 degrees west, then he must cross 0 degrees, then he must go to another 150 degrees where the particular location is placed. So 300 degrees of travel, 300 into 4, 1200 minutes of difference will be there. When we calculate this concept, when 20 hours are subtracted from 11 p.m., it will be 3 a.m. Saturday. Even if you follow the concept of calculating the time based on international dateline, or even if you consider calculation of time by coming towards prime meridian and going to western longitude, both will give you the same answer. One more example. The time at 150 degrees west, 1 p.m. Instead of going to anti-meridian and going to 150 degrees east, so it's the same process. 150 degrees to 0, 0 to 150 degrees, the same method, like you will get 1 p.m. on Sunday, you have to add 20 hours because the direction of travel is towards east on the globe. Then when 20 hours are added, 1 p.m., when you add 12 hours, it will become 1 a.m. Monday. When you add another 8 hours, it will become 9 a.m. Monday. Without considering international dateline, even if you consider international dateline concept, the same answer you will get. This is end of this India size and location chapter. Our next chapter will be India relief features. Before I wind up this session, it is important to mention the famous person behind geographical concept is Eratosthenes. The father of geography is Eratosthenes, the person responsible for developing or explaining the concepts of latitudes and longitudes was Hipparchus. Hipparchus was responsible for developing the concepts related to latitudes and longitudes, and the father of geography is Eratosthenes. Thank you. Thank you, Varun.